So my name is Alain Bresson from the University of Chicago, and I would like to thank Aegaea for giving me the possibility to chair this session right now. We have a new session on archaeometric researches, and without further ado, I'd like to introduce the first speakers. Long list: Maria Cristina Caggiani, Alessia Cioccato, Germana Barone, Paolo Mazzoleni, Simona Ranieri, Janeliczka, Peter van den Nabel, Pier Paolo Lotici, Gioconda Lamagna, Angela Maria Menenti, and Danilo Bersani, all for the University of Catania in Italy. I suppose it's Maria Cristina who will introduce the paper. The title is Engraved Gemstones of the Paolo Orsi Regional Museum, Syracuse, Sicily. So, in situ Rayman investigation. Okay.
So good afternoon, everybody. I'm going to present the results of an in situ archaeometric Raman investigation on a group of engraved gemstones of the Paolo Orsi Museum at Syracuse, Italy. The work was carried out by a group of researchers, as you can see, comprising both archaeologists and archaeometrists of different provenance. Indeed, we are not all from Catania University. The perspective is that of a truly interdisciplinary work, integrating the archaeological and archaeometric points of view. The latter is personally mine, for example, and the latter provides the know-how about gemstone identification and also different Raman instrumentation from different European universities. So the context of the work is the Paolo Orsi Regional Museum in Syracuse, Sicily. In detail, a collection of gems and jewels belonging to the Medagliere section. This was opened in 2010 to display an old and famous collection of coins and medals. A part of the sector is dedicated to jewelry, including pieces dating from the prehistory to modern age, illustrating the changing of techniques, fashion, and tastes throughout the century. The aim of this work was to characterize a selection of objects of Hellenistic and Roman age. They were chosen for their questionable classification. This questionable classification can be due, for example, to the fact that in private collection there can be miscellaneous materials. So the aim was that to support, integrate, or if necessary, I'm sorry, there is a problem. I just check this right now. So, okay, should be okay now. So the aim is that to support, integrate, or if necessary, discard the autoptic identification. And all this must be done employing advanced and non-invasive analytical techniques. The questionable autoptic identification may derive from the complex silica varieties classification. In fact, we must distinguish macrocrystalline silica, namely quartz, that can be differentiated in many varieties according to color, habit, or inclusions, and micro or cryptocrystalline silica. This is generally called chalcedony and can be divided into fibrous and grainy varieties. Sometimes there can be some confusion around all these different definitions. So the analyzed gemstones were 41, of which 26 were engraved gemstones. The samples include loose gemstones belonging mainly to private collections and jewels from archaeological excavations. The decorations consist of mythological representation, war theme, human faces, animal subjects, and inscriptions. Among the archaeological provenance, we can cite the Civil Hospital excavations and the Hellenistic Mausoleum at Syracuse, the San Giuliano site, and the Tindari excavations. The technique employed is portable Raman spectroscopy, which allows to carry out the analysis in situ directly in the secure rooms of a museum. In particular, two different instrumentations were used, equipped with different wavelengths of excitation, the 785 nanometers and the 532 nanometers lasers. The possibility of exploiting different lasers allows sometimes to avoid or reduce fluorescence background of the spectra, or to enhance the signals due to the resonance and pre-resonance Raman effects. Here I show you a few Raman spectra of typical gemstones used in the antiquity. In the gemological field, Raman spectra interpretation can benefit from the presence of different databases, both public and collected in peer-reviewed publications, to which many authors of this presentation actively contribute. The study of the spectra, that may appear straightforward, nevertheless requires the proper background expertise and proceeds with an accurate comparison of position, shape, width, and relative intensity of the peaks. Here I'm going to show you some representative results, divided according to the previous autoptic identification. So the gemstones classified as amethyst, the purple variety of macrocrystalline silica, were three. Two of them revealed the Raman spectrum of quartz, easily identified by its main peak at about 463 centimeters minus 1. Therefore, for these two gemstones, the attribution could be confirmed. The third one, instead, is surely not amethyst. It is a gold ring belonging to the Marchese Castelluccio private collection, and is an extremely important and unique sample due to the engraved Caesar's head. The Raman spectrum surely excludes quartz-linked nature of the gemstone. Broad photoluminescence bands may induce to hypothesize that it is made of glass. Indeed, purple glass is attested to be used as an amethyst imitation in jewels in different epochs, including the Roman one. Nevertheless, in our opinion, these precious objects deserves a further investigation, still with non-invasive, but possibly with fixed laboratory instrumentation that would not only allow to confirm or discard the preliminary glass interpretation, but also, if confirmed, to investigate the glass composition. So, going on, most yellowish to reddish gemstones were classified as carnelian, a fibrous variety of chalcedony. The Raman spectrum reveals the principal peak of quartz, already observed for amethyst variety, but here it is associated to that of moganite at about 502 centimeters to the minus 1. Finding pure moganite is extremely rare. Usually it occurs as intergrowth in several varieties of microcrystalline silica, leading to the interpretation of a generally called chalcedony. Chalcedony is indeed a general definition, also including carnelian. Therefore, these classifications can be considered correct, this one. Differently colored gemstones, such as those I show you in this slide, were classified as agate and onyx, other varieties of chalcedony. This identification was confirmed only for the sample on the left, the one with the raw deer engraving, while the other one, characterized by Aries figure, appeared made of macrocrystalline quartz, since moganite signal is absent. In the spectra on the left, we can notice how using two different excitation wavelengths can allow to improve the Raman signal intensity. In one case, a gemstone classified as jasper did not reveal any Raman spectrum, but only fluorescence, hindering a confirm of the classification. It is interesting to notice how of two green gemstones in gold rings, only one of them, found in Taormina and belonging to private collection, is actually emerald, while the other one, the engraved one, coming from an archaeological excavation in Agrigento, was instead made of a microcrystalline silica, as revealed by the Raman signals of quartz and moganite. so chalcedony. Concerning the garnet identification, only one of the two rings classified as such received a confirm by Raman spectroscopy, the ring with the two fishes from the Hellenistic mausoleum of Syracuse. The other one, with the soldier head engraved in a dark red material and found in Tindari, in association with other glass ornaments, is surely not made of garnet, but probably of glass. Other non-engraved garnet gemstones were analyzed, and though they have different provenances coming from Syracuse, Morgantina, and the Naxos excavations, they revealed a very similar composition of the garnet, as can be seen from the Raman spectra. So prevalently consistent of pyrope, which recalls to a possible common origin of the gemstones. A medallion mounted on a necklace was classified as glass, and this attribution could be confirmed. Finally, a new identification was added regarding a ring with an orange engraved gemstone that revealed to be made of chalcedony, as could be imagined. So, summarizing the results for the engraved gemstones, we can see that a great part of the identifications was confirmed, especially those of chalcedony, followed by amethyst, garnet, and glass. The not confirmed attribution regarded amethyst, emerald, and garnet. Very few gemstones couldn't be identified, and the new attribution was added. In conclusion, we can state that a predominance of microcrystalline silica varieties was found, followed by quartz and garnet. From an archaeological point of view, it is interesting to underline how two rings of the same context, the Hellenistic mausoleum of Syracuse, resulted made of different gemstones, and how the interpretation of a very important ring, the one with the Caesar's head engraving, was questioned. In fact, provided that the setting could be interpreted as a 19th century one, and that the gemstone may be actually glass, this does not preclude the antiquity of the gemstone itself. So a deepening of this study is encouraged. From an archaeometric point of view, we can conclude that in situ Raman spectroscopy is effective in the gemstones identification, and that the short time required for a single measurement allows a high number of identifications in an in situ campaign with different instrumentations and different researches involved. Therefore, this technique, though of course not replacing them, can be successfully associated to the competence and knowledge of archaeologists and art historians. For further information on this work, I suggest this publication on applied spectroscopy. I thank you for your kind attention and the organizers for this opportunity.
Thank you so much, Maria Cristina, for this wonderful presentation. I'm sure there will be many questions that actually reveal us a lot of aspects. We'll have the opportunity to discuss that later, certainly. But now I'd like immediately to move to the next paper by Athena Chroni and Lilian Karali. Athena is from the National Technical University of Athens, and Lilian from National and Capodistria University of Athens. And the title of the paper, it's Athena, and we will present Integrated Gem Documentation. The floor is yours.
Okay, so
yes, now I'm muted. Good afternoon. I would like very much to say a big thank you to to Professor Lafley, to you, and to all the organizers, and certainly also to the presenters, because all the presentations are till now extremely interesting. I have chosen a subject together with my ex-student and a very nice colleague now, Dr. Athena Chroni, and I would prefer her to present it to you. My sincere thanks again.
Thank you, Mrs. Karali. Thank you, Professor Karali. So let me present you our paper. Good evening, everyone. We really enjoyed the conference. All the presentations were extremely interesting. So this presentation concerns the launch of the respective IGD, that is Integrated Gem Documentation Research Program, inspired by the purple producing species distribution pattern as emerged from the related GIS study project by Professor Karali and Professor Konstantinidis, already developed to trace purple dye trade routes during the historical period in the Eastern Mediterranean, a successful attempt towards this direction of study. The CMS corpus, that is the web-based GEMS database, is known to every one of us. Although having a strong documentation profile, does not allow immediate automated cross-checking of data the way a geographic information system would. In CMS environment, the starting point of an inquiry is the artifact. So, if we would try to seek information for my non-gems, we would move virtually in CMS, choose the appropriate folder, and open the related artifacts options. Clicking on the selected one, the related documentation is shown on our screen. Respectively, for an inquiry on my gems, we would repeat the same steps. Concerning the specific locations, that is Mycenae and Crete, the starting points, the centers of the Mycenaean and the Minoan civilization respectively, it is indisputable that the Minoan and Mycenaean seals are the most common surviving type of art after pottery, with several thousand known spread over various locations of the Eastern Mediterranean, southern Greece included, revealing the trading routes, political connections, prosperity, and decline of the respective civilizations. At this point, basic problems arise for the researcher: possible lack of metadata, lack of data georeference, and also lack of data correlation. It is at this crucial point that the GIS could accelerate our research by furnishing reliable additional information, enabling at the same time multiple operations that might contribute to increase the effectiveness of a research study. In order to present you the project, we are going to make use of two examples. Let us move to the island of Crete, which is located in the center of the Eastern Mediterranean. It is in Crete where the non-civilization develops centered on Knossos. During its heyday, the Minoan civilization spread beyond Crete to smaller islands in the South Aegean. If we click on Knossos, the digitized information pops out, one or multiple digitized artifacts, that is gems, in the specific project. For one more example, let us have a look at the Mycenaean period, which has been chosen for showing the application. The Mycenaean civilization, starting from Mycenae in the northeast Peloponnese, gradually spread to the south and east through the sea routes, so that for its heyday in the 13th century BC, to be able to recognize a homogeneous cultural sphere of influence of the Mycenaean civilization, at least in the Aegean, the so-called Mycenaean Common. The abundant findings of imported Mycenaean pottery in the Aegean islands and throughout the Eastern Mediterranean, as well as the development of on-site imitations, give the most important data. However, pottery alone does not prove the presence of Mycenaean settlers, nor does it illuminate the relationship of possible such settlers with the indigenous populations. The presence in the region of foreign burial or worship customs, which are closely connected with the people, and the writing as indicative of its language, give stronger indications. While in the CMS web database, the starting point of the researcher's inquiry is the archaeological artifact, in this case a gem, as we already mentioned. In the geographic information system, the starting point of the research is the location. Again, by clicking on the location of interest, the digitally registered information pops out. Referring to Mycenae, we would cite that grave circles A and B are groups of elite burials with rich grave goods that include many seals that are thought to be known, certainly in terms of their tradition and probably in terms of their place of manufacture. All the aforementioned data can be inserted in the GIS, become interactive parameters, and contribute to the dynamic procedure of pattern extractions. All the documentation available for a specific artifact concerning the specific georeferenced spatial point is inserted in the appropriate attribute table, which can also pop out and be displayed by clicking the appropriate digital buttons. Imagery of the archaeological artifact included as well. The entry of relevant information, that is GEMS, for additional spatial points can lead to the visualization of the interconnection of the archaeological excavations findings and contribute to the extraction of patterns of various kinds. To conclude, why a GIS? GEMS are encountered in a variety of materials, motifs, techniques. GEMS include a huge variety of themes such as human figures, flora, as well as fauna. Their overall interactive study can effectively contribute to draw conclusions on the natural environment as this was shaped in those specific time periods. Categorizing GEMS according to various criteria is a challenge, which can be successfully managed to a certain point by database. Correlating GEMS according to various criteria and visualizing the correlation results, given their extremely large number of different locations of the Eastern Mediterranean, is the next challenge. Studying the pattern of GEMS distribution in the Eastern Mediterranean and extracting related distribution models is one more challenge. The last two scientific challenges require comparative study of multiple data, such as materials, subjects, techniques, styles, consequently requiring successful and effective management of a huge volume of data of different quality. A geographic information system is called to handle this stage of work, enabling data entry at different layers of information, allowing thus management flexibility, comparative studies, statistics, and furthermore allowing visualization of all the aforementioned. Multiple such kind of information mosaic allow through the GIS multi-layering, the main feature characterizing a GIS, to draw conclusions about the translocal contacts of one location with another, thus revealing networks of commercial, political, and cultural character, sea and land routes, and more information figuring thus out the type of globalization network prevailing. As such, one could conceive within the specific chronological context. Cross-checking multiple data layered in GIS render possible the extraction of various kinds of scientific results, such as metrics and statistics, while the correlation in the aforementioned data can reveal politics and trade routes, as well as art and typology prototypes. The entry of information in different layers further increases the flexibility and reorientation of the study of the scientific object, as there is the constant possibility of showing or hiding layers of information inserted in the GIS, making thus possible to focus on different fields of study. Furthermore, the modular structuring of information in the GIS allows fast and flexible movement of the researcher between different layers, storage of various digital processes operated by the GIS, continuous enrichment and redirection of the research study. Moreover, a GIS on the distribution of Mycenaean and Minoan gems in the Eastern Mediterranean, interconnected with a GEMS database, can multiply the dynamic of both digital tools. So, the IGD project, a new approach for an extensive creative study of the seals already published can contribute effectively, resolving most of the researchers' crucial points of information and study. Thank you so much. Thank you for your attention.
Thanks to our two presenters or groups of presenters this morning for being really in time. We are perfectly in time. So we have now the possibility to have a quarter of an hour of discussion about the two papers. I have seen that there has been already a lively discussion in the chat, but maybe now it's the opportunity for everyone to intervene. Don't hesitate to raise your hand, and I tried to navigating between my screens to check everyone. Or if I don't see you, don't hesitate to maybe say a word in the chat that you want to intervene, and I'll give you the floor. Do we have a question on maybe to start with Maria Christina's paper? Karina, please.
Yeah, I wanted to ask to Maria Cristina if that gem with the Caesar would also be modern.
I'm sorry, can you repeat? I couldn't hear.
Posso anche parlare in italiano se
No, yes, I understand, but I couldn't hear.
Okay, I wanted to ask if that gem you had under Raman of the Caesar, where you got it, it's a glass. Couldn't that be a post-antique piece?
Yes, it could be. We need to analyze the glass because a composition of glass can differentiate antique. Yes, of course. But for this, maybe we need some deeper investigations with laboratory instrumentation. So these are preliminary results carried out. And with the composition of glass, we could say, maybe if we are lucky, we could have a composition that clearly tells us if it's modern or not.
Yeah.
If it is glass, because what's sure it's not amethyst, but the spectrum is quite difficult interpretation. So the other analysis, also other kinds of analysis, could support the glass interpretation or find another solution. We don't know. We aim to deepen this investigation because the object deserves it, I think.
Yeah. If you need dates for reference, I measured cameo glasses years ago, and it's in JDE.
Of course, thank you. Of course, I'll check them.
All right. Do we have more questions or comments, maybe, on the first paper? I'd like to say myself that I'm a big fan of archaeometry. Working on coins, it's so useful, of course, to have an analysis of metal that changes completely our approach in some cases.
Yes.
And reveals a lot of things that are completely unknown. So it's beyond the traditional form of observation that allows us to make sense of what was really going on, and especially from the case of possible imitations or even modern forgeries that you just mentioned.
Yes, and we need to interact because our analysis without your interpretations doesn't mean anything. So we need to be always interacting with each other.
Yes, it can be also a way to bypass the question of price in antiquity. If you can find maybe something that looks like, let's say, amethyst or cornelian, but it's poorer quality, it reveals a lot. I mean, the intention to it's an ancient imitation, but just to make sure that everyone thinks that it is, but it is not actually. That's
and
really
statistics could be made with a solid basis, you know.
Hello, Maria Cristina. Can
Hello?
you hear me?
Yes.
This is Kathy Sass from Belgium. I'm going to try to share my screen again. Yeah. This is an ear pendant that was found in situ in Belgium. And at first it was thought that that it was all emerald because it's a very fine gold ear pendant. But then after some research, it was discovered that the two hexagonal beads on the pendants below, that is variscite, so that is not emerald, but it's a precious stone that is a slighter, badder, a worse quality, and the two inlays is just glass. So as Alain said, is it a replacement? Is it to make it cheaper, but to make the buyer pay the full price? I think that that maybe we'll certainly never know, but it is something to think about. Yeah, absolutely.
Yes, of course. Thank you for your information.
Do we have more comments, Joanna? Please. I cannot hear you.
Mute.
Sorry, I moved this out of the way.
Okay.
Yeah, no, I just wanted to say I'm very excited about the prospect of being able to use the CMS via a GIS, because it's very frustrating. I find the CMS website, as even though I've used it for years, is still a very difficult site to navigate. And so I was pleased to see your paper.
All right. Yes, we can
yes.
also now move to Athena. We can mix the question if there are any questions also on Athena's or Maria Cristina presentations. Don't hesitate.
And I would love to see something similar for other areas, but as we know, so often seals don't have a particular fine context.
I have to agree with Joanna. Our intention is to have a user-friendly application. What you have just mentioned about the CMS, yeah, it's a bit not so friendly, let's say, for navigating. The IGD project is oriented to researchers and students as well, so that the new generations of researchers must get used to this kind of research, digital research, and moreover, GIS offers this friendly way of correlating data and extracting patterns and results. If we could say, we could characterize it like this. Yeah.
Thank you.
Thank you.
May I ask a question to Athena right now? Did you already perform further analysis, like you mentioned, network analysis? From a student from Chicago performed a very fascinating network analysis on gems and amulets, but not taking into account the location. It was based mainly or only on the motif and the iconography. So I think what is fascinating in your database that you include the location. Did you already get, or maybe some people around you or students, have you already performed network analysis to trace, for instance, the connection from one site to the other, or routes, or trade, or using your database?
On Have you finished? I can't hear you. Maybe the connection. You have concluded? I don't. Can you hear me?
Yes, I can hear you right now.
Okay.
Did you perform any network analysis on your data on the basis of locations?
Yeah.
Trace.
What I was about to mention is that the IGD research project is just being launched. So we are studying the research. And as I already mentioned, this was inspired by Professor Karali and Professor Konstantinidis already applied research program on purple dye trade routes. So what we are intending to do is to find out, to reveal this kind of networks in the Eastern Mediterranean concerning Mycenaean and Minoan gems. But of course, it was well understood that this can expand to more fields of artifacts, of periods, of whatever one researcher could insert in the GIS and multiply the GIS or interconnect the databases. We have multiple choices. New technologies offer us multiple choices.
And also, if I can add something, for example, in the purple dye project, we could distinguish the different price, the different value of the final artifact, because this final product depended, for example, of the marine species, because there are some subspecies of murex who have different color. So some were red, some were violet, some were blue, and so the price was different. And all these places and the traffic of the purple dye has a new value now. We understand different things, social reasons, economic reasons. So there is a different pattern, a different meaning. And we hope to find this also through the study of the seals this way, because probably, for example, some seals that represent the world of the sea, for example, the octopus, or other fishes or other mollusks or whatever, probably have to do with places who are very close to the sea. So if we find them in the center, for example, of mainland Greece, it means something different. And the same is for seals with ships on them. So it depends where we find them. And the important thing is also to study the geomorphology of the time, because at the time, you know, specifically in the area of the Aegean, a lot of differences of the landscape have happened till now. So I think we are going to have a much better image of all this, a better picture and a better understanding, because the meaning of archaeology, I think nowadays, is not only the history of art, but the history of the human being in general, the whole life. So we will try to approach the whole, from a holistic point of view, the life and the way and the why people were in connection, because they could be in connection because they have been occupied from other people. They could be connected through friendship or through economic reasons or whatever. So we will try behind the beauty, behind the importance, behind the value, to see how people moved and what people wanted to do and what happened to them. So this is what we will try to do. It is a very difficult job, but Athena and I, we will try to realize it the best we can at the end.
Thank you for your comments, Dr. Karali, Professor Karali. I would like to, there is a question in the chat by Angeliki Livery to actually to the two of you. I can read the question. I know the CMMS, also the database of the Heidelberg University. Have you worked together? What new aspect do you bring? Maybe Angelica, you want to comment more? If you can unmute yourself.
Mrs. Professor Karalia, would you like me to answer the question?
No, go ahead, Athena, and I will continue.
Okay. The new dimension is the location, as we have already mentioned. Yes, I have already mentioned that the CMS is a very strong documentation database. The problem is that it's not so user-friendly, and you don't have the dimension of the location, of the geo-reference of the artifact. What a GIS offers plus is the georeference, so that this is the element that permits to make correlations and reveal patterns, reveal networks, reveal connections between city-states, or any kind of pattern one would like to reveal according to the data one is going to insert in the appropriate database, that is the GIS database, because GIS is also a database, but it's layered and it has the dimension of the georeference of the location. That is the new point that we are.
If I can add, I can say that we can play a little bit with the questions with this kind of database. We can try to answer different questions, as I stated before. And these questions are very important because, you know, all the seasides of the Aegean, of Turkey, and of the Ionian Sea have changed a lot, really a lot, and are still changing. So I think we will understand much more why some representations, when we don't know, and why some places are very important, why people moved from this side to the other. So we can make different, and chronologically, if in one period we have more seals dealing, for example, with the sea world, or more seals dealing with the land products, or more seals dealing with religious matters. And I think this will be a multiple approach, as we stated before.
Hello, thank you very much. Thank you very much. Very nice. I will try it. I will try to use. Thank you.
Okay, we are now at the end of our session. I would like to thank our presenters of this morning, thanks the audience also for their questions. And so there is now 12 minutes break before the next session. And I suppose that those who want also can go on chatting with one another during this break. But otherwise, we'll meet again at 7 p.m. Thank you.